Good morning to all of you. Today we will discuss about electric potential due to electric dipole. There are two derivations of electric potential due to electric dipole. One is axial position and other is broadside position. Both questions are very important. In this session, we will cover about electric potential due to electric dipole in axial position. First of all, we understand what is electric dipole. Electric dipole is a system in which two equal and opposite charges are situated very close together. Here, an electric dipole A and B is made up of two charges plus Q and minus Q are situated very close distance to L. From the midpoint of dipole at r meter distance, a point P is situated or C is situated. At that point, we have to find electric potential due to electric dipole. Here electric dipole, the effective length of electric dipole is 2L. So from midpoint and B, in O and B, distance between O and B is L and distance between A and O is also L. So from the distance between B and C, and from the charge plus Q and point C, this distance will be equal to R minus L. This distance is equal to R minus L because here is distance R, this is L. So distance between B and C, R minus L. So this is the distance of R minus L between B and C. Similarly, distance between A and C, R plus L, because distance between OC is R and distance between OA is L. So whole distance between A and C is R plus L. Okay. Then we will find the formula of electric potential due to electric dipole in axial position. So we know that electric potential due to a point charge. Electric potential due to a point charge. Then electric potential due to a point charge. Electric potential due to a point charge. A point charge plus Q is V1. So V1 is equal to 1 upon 4 pi epsilon naught epsilon R Q upon R minus L. This is the equation number first. In electric potential at point C due to positive charge plus Q, V1 is equal to 1 upon 4 pi epsilon naught epsilon R Q upon R minus L. That is equation number first. Another way, electric potential due to minus Q charge at point C is V2. Then V2 is equal to same here formula 1 upon 4 pi epsilon naught epsilon R Q upon distance between A and C is equal to R plus L. So 1 upon 4 pi epsilon naught epsilon r q upon r plus L. This is the equation number 2. By the principle of superposition, equivalent voltage V is equal to V1 plus V2. So that is equation number 3rd. From equation 1st, 2nd and 3rd, we put the value of V1 and V2 in equation 3rd. Then V is equal to 1 upon 4 pi epsilon naught epsilon r q upon, this is minus, so q upon r minus L plus here minus 2 charges, so minus 1 upon 4 pi epsilon naught epsilon r q upon r plus L. In both equations, we see that 1 upon 4 pi epsilon naught epsilon r q will be common. Then V is equal to 1 upon 4 pi epsilon naught epsilon r q will be common, so that 1 upon r minus L plus minus minus 1 upon r plus L. Okay. Then implies that V is equal to 1 upon 4 pi epsilon naught epsilon r q r plus L minus r minus L upon r square minus L square. Here cross multiplication, r plus 1 multiplied by 1, r minus L multiplied by 1, then both are multiplied by b. Then a plus b and a minus b equal to a square minus b square. So V is equal to 1 upon 4 pi epsilon naught epsilon r q r plus L minus r minus L r plus L. When minus is multiplied by r, positive r, then plus minus minus r plus L upon r square minus L square. Okay, here r and r will be cancelled. Then V is equal to 1 upon 4 pi epsilon naught L plus L. L plus L, 2L multiplied by Q, so it becomes 2QL upon R square minus L square. But 2QL is equal to P. That is called electric dipole moment. So V is equal to 1 upon 4 pi epsilon naught epsilon r P upon R square minus L square. If R is much greater than L, then L square can be neglected. L square can be neglected. So V is equal to 1 upon 4 pi epsilon naught epsilon r P upon L square can be neglected. L square can be neglected. So P upon R square. This unit of electric potential is volt. So this is the mathematical expression of electric potential due to electric dipole in axial position. In next video, we will discuss about electric potential due to electric dipole in broadside position. So subscribe for the next video. Follow my page and subscribe my channel. So today this is very important question of electric dipole, electric potential due to electric dipole in axial position. We will meet